My name is Anna Verbe. I'm a PhD student at the Institute of Movement Science in Marseille, France. I'm working on the aerial writing reflex in hoverflies. Hoverflies can hover and stay still in place around flowers. The writing reflex is a reflex where animals, once placed upside down, write themselves. You heard maybe about the famous writing reflex observed in cats. First of all, let's recall the two types of writing existing. The first one is the inertial writing, where changes in moment of inertia lead to rotation of the body. The second type is the aerodynamics, which means that an asymmetric wing motion leads to rotation of the body, like in pigeons. Indeed, birds, to rotate themselves, use asymmetric flapping. The question is, so how hoverflies write themselves? With aerodynamic or inertial means, or maybe a combination of both inertia and aerodynamics? To answer this question, we place the fly upside down on the top of a box, as you can see on this figure on the left, and on the photography on the upper left, the legs of the fly touching the surface. To constrain the fly in this position, we used a vacuum source. And when we stopped the vacuum, the fly fell. We used a fast camera at 1600 frames per second to observe the writing. The writing can be seen for one trial on the right. Steps of the writing can be seen on the left panel for one trial. The time of the steps are indicated by the number on the left of the photography. Hoverflies reorientation lasts 6 wing beats and about 49 milliseconds. We analyzed the wing motion of the fly, and as expected, we have shown that the fly uses asymmetric wing amplitude to achieve a complete rotation. We also analyzed and looked at the head and body angle through time, as you can see on the figure on the right. And we observed a time lag between the body in orange and the head in red. The body rotates before the head with a maximum time lag of 16 milliseconds. We made a dynamic model to explain the time lag between the body and the head. And we made the hypothesis that two nested feedback loops stabilize respectively the angular speed and the angular position using the halteres and a neural integrator. Halteres are organs that work basically like gyroscope to measure the body angular speed. We have shown that the feed-forward control, based on the haltere at the input, and controlling directly the head orientation at the output, accounts for the time lag between the body and the head. We know that flies stabilize their head to compensate body perturbation and stabilize the fly gaze. This reflex is based on the perception of body perturbations thanks to the halteres. We made the hypothesis that flies stabilize their head during the writing, leading to the observed time lag. Thank you for your attention.